and today we are going to be talking about connecting to web applications. So you can follow along at this URL right here, or there are also slides here, so I suppose I can put that right there. That's what we're going through today, and you can access the slides right here. All right, so just get rid of that, and we are off. All right, so connecting to web apps using MetaMask and ethers.js in web apps. So hopefully by now you guys are all familiar with MetaMask. This should be a very familiar icon. And MetaMask is more than just a browser connected wallet. It also offers web pages the ability to connect to the Ethereum network, or honestly any Ethereum protocol compliant RPC server is, I suppose, technically or more broadly what MetaMask allows you to do, because you can configure your own networks. So we are going to talk about adding Web3 functionality to regular web browsers, or that's what MetaMask does, and let's take advantage of that now. So MetaMask is a browser extension. It is also a Web3 provider. There are a number of different types of Web3 providers that operate in a bunch of different contexts, and MetaMask is a Web3 provider that operates in the context of a web browser. It operates, or it provides an RPC interface to the web page, whatever web page you're browsing, through an injected Ethereum object. So if you're not familiar with JavaScript, you can, there is a single global JavaScript object in a web page called the window object, and that is, that's the single object that kind of contains everything else in the page. So you can access the document from there, you could access cookies or the URL from there, you can launch other windows, you can do lots of stuff from there, and that's where all the APIs are stored and stuff. So MetaMask just adds another accessible API to the window object, and it is called the Ethereum object. It used to be called Web3, and they changed the name to Ethereum. So we are going to interact with MetaMask in two primary ways. This is kind of their new and improved interface. We have this request method that we can use to send RPC requests. Is everyone familiar with what RPC stands for? It stands for a remote procedure call. It's just a paradigm for writing APIs. And then we can also listen for events. So remember your Solidity events that you can emit, for example. You can add listeners, but MetaMask has other events that you can also listen to. So add listener to a MetaMask event, one of which could be a Solidity event. And we'll also feed the ethers.js library, the window.ethereum object, and we can interact with smart contracts pretty easily in that way. All right, so the very first thing that you're going to want to do when you are programming with MetaMask is you're going to want to connect to MetaMask. So connect your web app to MetaMask. You use that using this fairly simple RPC, or it's not it's an RPC call just to MetaMask, and it looks like this. You just say window.ethereum.request. What's the method we're requesting? We're saying Ethereum _ request accounts, and that will get us a list of accounts that are available to us. I believe right now, the way that MetaMask has it implemented, it will only ever return a single account in an array, so an array of one element, just containing that account. And the reason it returns an array is for future proofing, because they might add that functionality later. At least that's what it says in the docs. Right, so this is simply how you prompt MetaMask to connect, or prompt the user to connect MetaMask to the web app. Right, then we can, after requesting access to accounts, we can always go back and check what accounts we have access to with this very similar looking method right here. Oh, and I suppose I should discuss this await keyword. I think we'll actually get to that. Right. Okay, so those are two RPC calls that you can use. And then add listener. If you are familiar with the event-driven programming paradigm that is very common to JavaScript and related languages, this should be fairly familiar to you. The add event listener, remove event listener type of paradigm here. So we can add a listener to the Ethereum object, say ethereum.addListener, for when the access to which accounts we have permission to access changes. Then we'll get this list of new accounts here. What are the accounts that we now have access to? So that these types of events would be fired when, so if I have my MetaMask here, and I suppose I need to import my Ganache account again, because this is a different computer from, or a different operating system from last session, because I had some OS trouble, so I had to reinstall everything. So a little bit of repetition going on here. So this type of event, this accounts changed event, would be fired when the user does this. There's account change right there, when you switch what account is active on your MetaMask. So that is an accounts changed event. Usually, I believe it's recommended that when you receive an accounts changed event, you just reload the page. I think that is, according to the MetaMask docs, that's just like the safest bet, to just reload the page and restart everything from scratch using the account that the user just changed to. All right, so we have a full React project that uses MetaMask available in the repo. So if you go over to, of course I don't have it open. Right, so go to GitHub and go over to Web3 TTT. So if you go over to our GitHub right here and clone this repo, however, then under examples number 5, this is a sample Web3 app written using React. So I have that pulled up right here. And let's see here. I want to npm run. Okay, so your instructions for getting this up and running on your side. So you should already have npm installed. We installed that last session, npm. If you don't have npm installed, that would be something you can get from Node.js. Right here, nodejs.org. Just get the LTS version. And then you would switch over to the Web3 TTT/example/5 directory and run npm install. I've already run it, so this shouldn't take very long, because it should say, okay, you already have everything installed. There isn't much to do, right? So you run npm install. It'll give you this massive node modules directory here. And then you say npm run start. And this should hopefully start up a local development server, and you will be able to see this project running and in action. But now let's take a look at this hooks section here, connection.js, all of our hooks here. Oh, and here we go. All right, well, while that's loading, we'll go through this. Okay, so how many people here are familiar with React.js?
I am, to some degree.
Okay.
More Angular, but yeah.
Angular, okay.
More Angular, but yes, React, I played with it.
I'm a little bit familiar, but I wouldn't call myself like proficient in React. Just like
Okay.
I can get by it, but nothing special.
You are, Lincoln?
I'm the same as Sungyu. I mean, I know a little bit, but nothing crazy.
Okay. Okay.
I've used it quite a bit.
All right. Perfect. Perfect. And if no one else responds, I'll just assume that that's not much experience. There is some right here on the website. This is the React tutorial that you can run through. React, so I have experience with kind of the big three in web development, Angular, React, and Vue, red, green, and blue. My favorite is React by far. So this is my personal bias. I just prefer React over the others. We don't need to get in.
I'm starting to like React because it seems a lot more intuitive. Angular is just this. It's really It's like a jungle.
I appreciate Angular in very large projects because it has a lot of in my experience it kind of forces you to develop in a specific way. You have all these structures and services and stuff like that. It's structured and kind of heavy-handed in that regard. So I appreciate that for larger projects, but I really like the freedom and the flexibility that React provides, and it seems to be a little bit lighter on the boilerplate. So that's my quick reasoning for preferring React. That is kind of beside the point. We are just going to use React for this project because largely because of the smaller amount of boilerplate. And also because I like it, and I'm the one who wrote the course. So, we'll go through a little bit more in depth of what's going on with React here, since not everyone appears to have experience with it. So, I suppose let's maybe start from a little bit higher level. Okay. So everything technically starts from index.js. All this does is, so one very unique thing about React is that, so it is a component-based library, and it allows you to use what's called JSX syntax inside of your JavaScript. So it looks like HTML code inside of JavaScript code. And this is just special syntax that is unique to, not unique to React, but it is unique to, it's not a JavaScript feature, it is a React feature. And this allows you to instantiate your components in a way that looks more like how they appear on the DOM, the document object model. Regardless, all this does is instantiates an instance of our app component, which it's importing from our app.js file over here. Most of the code in here is fairly well commented, so I'm not going to go through everything too deeply. We'll just go over this on kind of a more surface level. As far as React goes, I make heavy use of what's called composable functions in this project, and composables usually begin with a use. They're functions that begin with the word use. That's just a naming convention, and they have special React state variables come out of them. So use connection is a composable function that I wrote. Use state is one that is built into React. The way that use state works is it will return to you a regular appearing variable and a function that you can use to change the value of that variable. The reason being, this variable is actually controlled by React and monitored by React, so that any changes to that variable will be reflected where that variable is used. So you're not going to have to call special update functions. React, the library, will compute where it needs to perform updates based on when you call the setOwner function or the setBalance function. So essentially you have these state variables. Oh, and this is the default value right here, or the initial value. So owner is going to start out being an empty string. Whenever we call setOwner, it will let React know to update the value of owner wherever it's used, and it will also tell React to update the document object model so that those changes are reflected. Right, so we just are initializing 3 different variables here, one of which contains the owner, one of which contains the balance, one of which contains the number of events. So you can see here I have a closure where we are incrementing the event count. So, oh, I did not want to click that. The way that these set state variable functions work, you can either directly pass into them a value, or you can pass into them a function that will take the current value of that variable and then will set that variable equal to the return value of the function you pass into it. So the way that this would work here is set event count. C is going to be the current value of event count, and then it returns C plus 1. So that means that event count is going to end up being incremented by 1. Let's see. Use effect. This is a composable that will run a predicate function right here anytime one of these state variables here is updated. So that means anytime our connection state is connected, or the address that we currently have access to, anytime either of those two update, this function will be run right here. What this function does, it checks if we're connected. It resets the event count to 0. So you can see here we're passing in a concrete value as opposed to this function. We have a contract, which we are pulling from here. This is from the ethers.js library. We're instantiating a new contract. We'll talk about this code a little bit. Contract address, that is going to be incorrect because this is an address that I was part of a blockchain from a few weeks ago that no longer exists. So what you're going to have to do is go over to example 4 here. So say examples 04, and then say truffle migrate. And hopefully I set up everything correctly again. And then if this deploys if that deploys my contract here, oh, come on. Hold on. There we go. Oh, do I have to save him? Okay. So we will migrate that again to get our contract address so I can update this. All right, lovely. Lovely, lovely. Where's my contract address? All right. There we go. So I'll just update this. All right, so that's going. So this constructor here, this ethers.contract constructor, takes in our contract address. Then it takes in our contract ABI. We talked about the ABI a bit last time. Let's look. Well, okay, so we can get the ABI from a couple of different places. One, when we build our contract here, there's actually a field right here called ABI, and you could use that for your ABI. Otherwise, I have also generated this file right here, which is just the ABI, not wrapped in any other JSON information. And I got that by running, oh, whoops, I should have been in that. By running sol cjs-ABI, and that would be contracts pyramid scheme.sol, and that will generate a ABI file right here. I obviously moved this around, renamed it a little bit, but this is should be the exact same file as this right here. Obviously, the syntax highlighting is different, but that's the only difference. Should be the only difference. So we pass in our contract address here to the ethers contract constructor. We give it the ABI so that the ethers library knows how to interact with our contract. And then we pass in provider.getSigner 0, and that is an index, so just the first signer. Provider this is where we are giving ethers our Ethereum object, our window.ethereum object, and then getSigner just gets the first available signer. And this will actually automatically update as the user plays with their MetaMask. This will actually automatically update. So that's where our contract is coming from. So we can go back to our useEffect call right here. We have contract.on. This is where we get events, our Solidity events, so we can listen to a sign-up event, and we get recruit, recruiter, and initiation fee. Let's take a look at our Solidity contract right here. I'll split this on this side, and we'll see, okay, so sign-up event, recruit, recruiter, and initiation fee. And those are going to come through in our JavaScript code just as arguments to our contract.on call. And then we actually have two different ways that we can listen to contract events. This is the simpler way, where you just pass in a string, the name of the event, and then you get these parameters back, and that's kind of it. So this would listen to every single sign-up event that gets emitted. Or you can use the ethers.js library to filter them a little bit, because say, for example, this is a very heavily used contract. You have a lot of users, then you might not want to see every single event that comes through, and you want to filter them a little bit. So Ethers gives you options to do that using contract.filters, and again, this is all coming from the ABI. And then you put the name of the event here, and you can filter it by address. So this is credit withdrawn address event, and you can only filter by indexed parameters, indexed event parameters. So I can't put amount here. I can only put the address there. Right, and then we get all of our arguments, and I just log those out to the screen and then call our increment event count, because we don't care that much in this web app what's going on. And then all this does is, we can ignore that for now. All right, what is going on here? Editor's acting a bit funky. Oh, goodness. All right. Then we have get owner of the contract. This is just a regular function that will set the owner state variable equal to contract.owner. That is a function call that, if you remember back from last session, when we were in the Truffle console, the ethers.js interface with a contract is very similar to the Truffle console interface with a contract. So we can just say contract.owner, call it like a function. It will go out and fetch that data from the RPC server. Get balance, very similar thing. Balance of, we find our balance of here. There's balance of, here it is. Balance of function, call it, give it an address right here. Then we convert that to a string. Perfect. Looks wonderful. So that's just very straightforward how ethers.js allows us to interact with Solidity contracts. let's see. We don't need to go through everything here. Although we should probably look at this. All right. So contract.buy, again, very similar to our truffle console. And then for the final argument, we can pass in this object with some options, right? With some extra metadata options like value, where we can attach some ether to our transaction and send it to a payable method, right? So ethers also provides us with some utility functions to parse maybe ether or convert way values and stuff like that. So just a couple of utility functions there. And then this is some of that React code. So let's see if our web app has loaded now. Hopefully it has. All right. So let's connect to MetaMask. It opens up right here. Oh, and I should switch what network I am connected to right there. All right. Oh, and of course, now since I refreshed my Ganache, I have a whole bunch of different accounts here now. So we will just import that guy. There we go. Perfect. Yes. Thank you. All right. So we will say connect to MetaMask. And since I killed it the first time, it didn't pop open again. Then we'll say next. Yes, connect. Thank you. All right. And now we are connected to our web app. So let's go into our code again here and see exactly what just happened there. So let's see. Provider. So we have this connect to MetaMask button. That was the first element that was displayed. Let's take a look at what's going on here. We have a simple connect to MetaMask function right here that is called when we click on the connect to MetaMask button. And that just calls, this is the exact same line of code as you saw in the slides. Await window.ethereum.request this RPC method. I suppose we should go over what await is. So async and await are actually just syntactic sugar for a very common method call. This window.ethereum.request function right here doesn't immediately return the result of the network request, right? Because a MetaMask has to go out and make a call to an RPC server somewhere on the network, get the response and send it back to us, right? And that takes a lot of time. So we don't just want to make our web app sit there and hang, right? We want the web app to still be interactive while that's occurring. So instead, what this actually returns is an object that says when the network request returns, this object is going to update to contain the result of that request, right? The response. And those types of objects that says, I don't have a value yet, but I will have a value soon, probably, hopefully, you know, they're called a promise. So this request returns a promise, and that promise will eventually resolve to the response to the RPC call. And in that case, it would be the list of accounts that the user authorizes the web app to use. For example, in this case, it's actually not just a network request. We're saying, okay, request of the user, and then MetaMask pops open a separate window and the user does some interactions, and that's going to take some time, right? But if the user just like X's out of it or whatever, you know, we don't want the, or if the user ignores it, we don't want the web app to just sit there and hang and be unresponsive. So async and await, what await does is it unwraps the promise into its response value. Of course, that means that the code has to kind of sit there and wait for that to happen. So that's why the keyword is called await. And async, you can only use await in the context of an async function. And an async function is a function that returns yet another promise. So this just kind of hides a layer of complexity. It hides essentially two different functions that are returning promise values. All right, so that is how our connect to MetaMask button that we just interacted with worked. Right, Now let's say call the balance. Oh, network changed. Okay. All right, I don't know quite what happened there. All right, regardless, it appears to be working now. Maybe it just let it sit for too long and it decided to stop cooperating. All right, but we have this balance button that we can click and it gives us a balance of 0. Let's say buy. I'm going to buy 1. All right, and then MetaMask should pop open here, or maybe it just is hiding. Come on. Oh, it works in testing, but not in real life. Not when I'm demonstrating. All right. Let's see here. What's going on? 0. 1. Okay. And it's saying I have an RPC error. Oh. Owner cannot buy more. Okay, right, because I'm literally using the owner account. All right, so I'll just add another account here. Import account. Let's use right there. All right, and we'll import this account. So we'll go over, say, import account. Yep, fabulous. We have 100 Ethereum. And you can see, or it should update here. Let's see. Oh, I need to connect it. All right, so let's connect that account. There we go. Now we can see here, this address begins in 9C34, and this is 9C34. Perfect. So let's say buy. I'll say 1, and it's still not liking it because I must sign up first. Okay, I didn't build that into the interface here, so we'll just do that manually. If we go over to here, say truffle console. All right, and then we'll say let instance equal pyramid scheme dot deployed, like so. Wait, right, perfect, instance. All right, and then I'll say instance dot sign up, and let's see, what do I have to pass into here? Sign up with the address of my recruiter. The address of my recruiter is this guy right here. So, that needs to be in quotes, like so. All right, so the address of my recruiter, and then I have to send in a particular value, an initiation fee of 1 Ethereum token. So I'll pass in value will be utils dot parse. Oh, come on. Web3.utils dot two-way, and then do I say 1 ether? I think that's how it works. All right, let's see if that does it. And it doesn't like that because I already signed up. Well, one side is saying I am signed up, the other is saying I'm not signed up. Oh, because I have to tell it where it's from. From, sorry, from this account right here. There we go. All right, finally. And we should, oh no, we're not listening to that particular event. All right. Oh, there, our sign up event came through the console. Perfect. Right, so now, finally, if, let's see, so that's my owner account. This is my not owner account. Now if I say balance, it should say, well, that's should be 1 Ethereum. So that should be with like 18. What is that? Should 18? Yes, perfect. So that is exactly 1 ether. Perfect. I can say buy. I'm gonna buy 1. All right, now MetaMask opens and it says, okay, we're going to buy 1 Ethereum's worth of these pyramid scheme tokens. MetaMask pops up, says, do you want to confirm this? I'll say yes, please confirm. It says success. All right, we should get, oh, hey, 1 transaction confirmed. Look at that. We have our transactions here. Contract call. Let's see, value 1 Ethereum right here. Calling the buy function that we just called. And now if I say balance, that should update to be 2. Perfect. I can say owner. That's the address of the owner. Perfect. Right. Let's take a look at the code and see what is going on here. So, let's take a look at this button first. This is a call view method button. It's fairly simple. Actually, this doesn't even touch ethers.js at all. That is literally just a UI component. We use them right here. So we have our call view method button, which for our balance and our owner, those show up right here, balance and owner. So you can click those to call the respective functions. And the function that it calls is here. We have get balance. That get balance function is right here. It sets the balance state variable equal to the result of, or the resolved value. That's what await means. The resolved value of calling contract.balance of on our address, which is the currently active MetaMask address. And then it converts it to a string because I think it'll give us back a big number variable because, as you may have noticed, Ethereum deals with very, very large numbers because everything is an integer. Because if you've worked with computers at a lower level before, you'll know that floating point, well, actually, even in just JavaScript, floating point numbers are not accurate numbers. So you always want to deal with integers, especially when it comes to anything financial. You always want to deal with integers because integers are precise and exact. Floating point numbers are not. So that's why we always have like, okay, Ethereum has 18 decimal places and Bitcoin has 14 decimal places. I don't remember. Yeah, that's why we decide to use decimal places instead of actual floating point numbers. Just a little tidbit of trivia there for you. Right, so that's what's going on in set balance or get balance, and get owner is very similar. And then we have this buy function that we looked at before as well. And that's just calling that buy. And you remember, these guys are just view functions, right? They're just view functions. So I can click these buttons willy-nilly and MetaMask doesn't really care. MetaMask says, oh, you want to do a view function? Great, I'll serve that view function to you, no problem. But as soon as I say buy, and I want to buy one ether's worth, oh, MetaMask jumps in the way. It says, you can't spend Ethereum without confirmation from the user first, right? So that's what is going on there. Hey, look at that, nice. All right. Perfect. So I think that actually, I should look into these hooks. We'll go through these hooks, and then that should be it for today. And we'll go through the rest because we're already 40 minutes in and we need to do other stuff today yet. So we'll go through this use connection and then that'll be it for today. So use connection is just kind of a nice React hook that I wrote that hopefully is generic enough that you can use it in your own projects as well, and you don't have to write all of this boilerplate by yourself from scratch, at least if you're developing your project in React. So we have here 2 state variables that we're declaring. Use state. Those just come straight out of the React library. One is the isConnected Boolean variable, and the other is an address, which will be either null, I guess, or a string, I believe. That would be a string. So we have this handler that takes in a list of accounts, tells updates our state variable to being connected, and we decide whether we're connected to an account by saying, okay, we have gotten a list of accounts and we have gotten at least one account in that list. Okay, we are connected to an account, right? Because we have access to at least one account. So if we're connected, then we set the active address equal to the first account that comes through, which, like I mentioned before, MetaMask is only ever going to give us one. At this point in time, they may update it to give us more, or have the ability to do multiple addresses at a time later. But for now, it's just one at a time. Otherwise, we're going to reset the address equal to null. What we do here is we check and see if we are connected by asking MetaMask if we have any accounts available to us. Remember, this f_accounts, that's not going to pop MetaMask open and say, do you want to connect to this web app? All this is going to do is say, hey, MetaMask, have you connected? Have you allowed us a connection yet? And MetaMask is either going to say, yes, here are the accounts, or no. It's not going to ask the user to give the web app access. It's just asking if we have yet. And then we have this use effect, which if we have this empty thing right here, I think that is going to run only once. So we have window.ethereum.add listener. This is adding an event listener onto MetaMask for whenever we change our accounts. And that is our handler right there. So accounts changed gives us a list of accounts, very similarly to how this guy gives us a list of accounts, and that is just going to run that same function over again and update our state variables. All right, so that is how the connection.js or the use connection composable function hook thing works. Hopefully you find some of these files useful in your own projects. Hopefully this gives you a little bit of a starting place, right? Because we have view function that you can call. We have a connect to MetaMask button. We have a place where we are calling a payable function. So hopefully that gives you all a good starting place to start working on your own web apps. We're not getting through quite the entirety of this section today, so we'll go through the rest of it on Wednesday. Now we'll do our project stat, or well, actually let's do our topical micro presentations next. Did anyone have a topical micro presentation covering any of these topics here, or even some of the stuff that we've covered in the past that you would like to share?
I used a little tool that I found a couple of days ago to help generate boilerplate code that helps you work with MetaMask.
Okay, and what's that called?
Well, it's on GitHub. I can share the link right here. And can I share my screen?
Oh, yep.
Okay, yeah. Let me just share this here. Yeah, this is the project. You guys can see it. Can you guys see it?
Yeah.
Okay, yeah. So, all right, that's the project, and you just use it's a React project, and you just set it up this way. You install it and set it up this way, and then once you launch the app, which I did. So here's the commands that I put in here to get the commands get the app launched, and what you get is this nice little app here with the connect wallet button already there for you. It'll hook into MetaMask and all that, and then I haven't explored the graph. They put in a graph API as well, so there's some graph API functionality in this as well. But it's probably another way to kind of get some boilerplate going, so that you can, and it's React based, you can get some boilerplate code going to if you want to build a mask that requires, if you want to build an app that requires MetaMask.
That's great. That's great. I love these projects that help people really get up on their feet really fast. It's great for bootstrapping an app really quick. Awesome.
Yep.
Yeah.
Cool. Thank you.
Yeah. If you're interested in more React hooks, here is another repository from Austin Griffith, who is pretty active in the Ethereum community. Highly recommend you take a look through all of his React hooks here as well. So there are a lot more for monitoring blocks and contract loaders and stuff like that. So definitely take a look there. I would offer a word of caution though. Whenever using the code that kind of hides all of this complexity, it's really important to understand what's going on a layer below, right? So for example, simpler example, if you are learning JavaScript, I don't recommend you start with React, right? If you are learning Web3 dApp development, I don't recommend you start with like these Ethereum hooks that I'm giving you here, right? Even if you know React, take a look at the MetaMask APIs, take a look at ethers.js, and understand that stuff first, especially if you're going to be instructing other people in how this works. Make sure you understand that stuff first, and then move on to using the more the easier to use stuff that covers up all that complexity.
Yeah, I typically use like the boilerplate stuff to do prototyping, and not really take it to production. Because you don't know what's there, and that's a risk, especially with cryptos. You don't know what kind of stuff is sitting in there. So
yeah, exactly.
and typically these projects, like the project that I posted, they're not audited by anything, right? And so, like ethers.js is used heavily, and lots of people are involved in it. So it's a little bit safer than this kind of rogue project out there that builds a scaffolding. But I think it's great for like prototyping and maybe digging into and learning. It's not like inspecting the code.
Yeah, definitely. It's like MetaMask is probably even more widely used than ethers.js or any of these other things we're talking about. But it's also covering up a layer of complexity. And I guess I actually haven't gone down the rabbit hole of like actually studying the intricate details of each RPC call that MetaMask is sending. But yeah, that would actually be a really good exercise for me.
I lost money with I lost a little bit of money with MetaMask and playing with Ganache, the GUI Ganache. There's a hack out there somehow that you can lose a little bit of ether, and it moves like I think Ganache starts up with some of these fixed addresses or something like that, and there's a hacker sitting on these fixed addresses on mainnet or something like that. And I did contact MetaMask. I lost like $3 or $5 or something like that. So, but yeah, these things are still, even though they're used by millions, they're still not. You can't be 100% sure about it, all of it.
Yeah, it's always yeah. It's like what do they say? Measure twice, cut once type deal. So better to double check. And be better safe than sorry type deal. So
absolutely.
Yeah. I can't say I haven't been burned either. So, but I mean, we're playing in dangerous waters a little bit.
Yes, it's the cost of learning. So.
Yeah. So, just don't use don't play with MetaMask if that's also your if you also have your live account on there. Use cold storage for that type of thing. All right. Let's see. Anyone else have a topical micro presentation that you would like to present?
Yeah, I do.
All right, let's hear it.
I was reading about upgrades to Ethereum 2.0 and some of the things that are still hindering wide user acceptance. So some of the things in 2.0 that they're looking to introduce are sharding and a change from the proof of work system to proof of stake, which is more based upon like the number of coins somebody holds. Also, the sharding system, which is meant to like split databases to reduce congestion on the network, is another concept they're playing with. But it's like the timeline is more set for 2022, and those are some of the things they're working on. However, a lot of it is not like going to affect the gas or energy requirements needed for a lot of these decentralized finance apps. So it's going to add a new interesting dynamic while also still having the same components from 1.0. And then some of the problems I mentioned earlier that the article highlighted that are preventing, I guess, wider user acceptance, or like it's not as intuitive for people like to just jump straight into a lot of these user interfaces and stuff. It's like, it could be a little bit complex and not enough. Also highlighted they feel there's not enough educational material for people to learn. And then because of that, they said it branches into a wider problem where they feel like it won't allow for a large, sustainable, decentralized finance ecosystem. But just some of the things I was reading about in that article, and I'll drop the link in the chat as well.
Awesome. Sounds great. Thank you so much. Yeah, Beacon Chain is coming. ETH 2. Awesome. Thank you so much. Very cool. Actually, yeah, if you want to post that in the Discord too, I should probably collect all these links and post them in the Discord when we're done. But yeah, if you want to post that in the Discord as well, so we can refer back to it after the session is done, that would be fabulous. Perfect. Okay, anyone else have a topical micro presentation? All right. So then I think we can move, and let me clean this up a little bit and share my screen again. All right. So let's move into our project status update here. Hopefully by now you have finalized your smart contract, or you at least have enough of it written that it is usable on chain now, and like you can deploy it and stuff, and maybe you've written a test or two for it. If you have done so and it's on GitHub, please share that so that other people can see what you're doing, maybe be inspired by it, learn from it. Also, we are going to move away from having each session be primarily me monologuing, because so this is session 7 out of 12, and we are going to shift now from me just going through material and talking all about it to you are going to start presenting your project, what you've been working on. The topical micro presentations are no longer going to be micro type of deal. So yeah, be prepared for on Wednesday to present a little bit about the project that you've been working on, and if you ran into an interesting problem or found an interesting library or something like that, found an interesting project, that's what we're going to be transitioning into. As for writing the web front end, I'd say that's where you should be focusing your energy now. If you are using React, feel free to use any of the materials that were presented today. You can use any of these simple hooks that I've written here. You can use the resources that were posted in the chat. We'll make sure that those get on Discord so you can see those later. And then as for hosting, that's sometimes an issue for people, not able to find a free place to host a website. So I've just linked a bunch of different resources. I have experience deploying to most of these. I haven't ever used Supabase before, but I've heard good things about it. Otherwise, I think I have deployed to all of these other platforms before, and they all have free plans that are very developer and Git friendly. So highly recommend you check out one of these resources here for deploying your site so that we can all use it too. Yeah, that would be fabulous. Even if, well, I suppose we'll get into testnet in a couple of weeks, a couple of sessions, but this is just something to keep in mind for now, so we can at least see the interface that you're working on. Anyone have a project status update for us now? Otherwise, we can end a couple minutes early. Everyone finished up writing your contracts, ready to start writing a web app?
Hell no.
What would you say is your biggest blocker?
Time.
Time?
Mm-hmm.
How is the contract writing going?
I got mine done. So I actually have mine deployed on the Kovan testnet too.
Oh, nice.
Yeah, it's working. There's the transaction that I had for it. Here's the contract address as well. So I'm happy with it. It's a little simple, so I may try to add some more to it. So the basic idea is you send money to this function call that's called mint NFT. And what it's supposed to do is it transfers Ethereum to this carbon credit token, but that's not on the testnet. So I just use the DAI stablecoin instead, burn it, and then it sends you an NFT for carbon offsetting.
Okay, nice. Yeah, I remember you mentioning this a little bit last week sometime, I think. Talked a little bit about your project. It's so cool to see it progressing, and it's actually live on a testnet now. You're going faster than the pace of the course.
Yeah, I had to, and I wanted to use the Uniswap integration. I didn't want to have to deal with all that on a local.
Nice. Awesome. Awesome. Yeah. Perfect. Well, this is great to see. Is the source code? Let's see. Is the source code of the contract on GitHub somewhere that we can read it?
I will send it in the Discord.
Okay. Awesome. Thank you. All right. Anyone else have cool updates around their project? Have you all finished writing your contracts? Or you have anything on GitHub to show off for us? Otherwise, that would be our time for today. Kudos to everyone for working hard, doing your micro presentations, and if you didn't get the attendance link, hopefully there you go. There's the attendance link one last time. Otherwise, that is it for today. We will finish section 5 on Wednesday.